We're now going to revisit the idea of k-means. So if you remember, k-means was a technique of using clustering, which is where we have a set of data and we want to find the hidden structure in that data. So we don't necessarily have a label. So if you remember, we looked at using Iris setosa, the Iris setosa data set of 150 flowers to determine whether or not we could predict through finding a cluster which particular cluster the iris flower was part of. And obviously we had three clusters. We know that we have three iris flowers, and we wanted to understand whether the sepal length, sepal width, petal width and petal length, so four features, have an effect on which cluster we end up having the iris plant in. So to this effect, what we've done is we have re-engineered this data to fit in with streaming k-means. So if you look here, we've provided in our test set a label which specifies, it could specify anything. It could be the name of an iris flower. For simplicity, I've called Iris setosa 0, Iris versicolor 1 and Iris virginica 2. But it doesn't necessarily have to be a number in that way. It can be a label of any kind. So so we can look at the training set, and we provide just a set of regular features in this way for the training set. But for the test data, because we need to accurately work out which cluster this iris plant is in, we include a label definition in this case as well. So what we're going to do now is we have a Spark shell. So we've logged into our cluster already. We've run the spark-shell command, and we are going to write some code which will allow us to execute this streaming k-means. So from the top, if we look at what we're doing, we are taking a 15-second window in the streaming context, and we're looking at directories called training k-means and testing k-means. So in the case of the test, you can see that we have a labeled point. In the case of the training, you can see that we have a vector. So we saw the dense vector type in the form of an array, and we saw the labeled point, which was the paired structure with the point plus the array. So what we're going to do is we then set the number of dimensions, which in this case is 4, and the number of clusters, which is based on the number of flowers that we have, the number of irises. Then we call train on once we've built our model and pass in the training data stream, and then predict on and pass in the test stream. And then we can push the results out to a set of text files, output text files. So let's have Spark interpret that, and what we can do now is we can start our streaming by calling ssc.start, and once we've done that, we can call await termination so that we can block on the current thread for our streaming. Now we've seen an error occur immediately, and that's because we haven't set up any training or test data. So let's do that, and we have iris training 1, so we'll upload that. And if you remember, we had our directory was called training / k-means, so we need to get that right so that it picks it up from the right place. And let's do the same for the test dataset. So iris test 1, and we will call this testing / k-means, and we're going to upload that again, and we'll take a look at this testing, and you can see we've already had a set of outputs that have been created, because every 15 seconds it's going to be looking for those new files, and it will look to train them, and it will look to to see whether it can produce us an output with the k-means algorithm. So let's take a look and see whether we can find some kind of output. It could be in any one of these time periods, probably earlier. Must have just missed this. And here we go. So you can see that we've got some output, so we'll download that and we'll call this results.txt and save that, and we'll open that from our desktop onto Sublime Text, and you can see here that we have the labels against the clusters that it's chosen from 1, 0, 2, 1, etc., etc. So some of them are actually fairly accurate. Now the interesting thing about this streaming is that if we keep looking, you can see that we actually the Spark software is still continually running at all times. So because we're picking up changes in both the training and the test set, what we could do is we could go back to our training directory here, and let's just upload another file and see whether we can coerce some more test output with a better model. So let's choose Iris2. We'll upload that. Oops, that's uploaded into the wrong place. So remember, the directory has to be exact. So we'll pick up the training, click on upload, and you'll see that we have training1.csv and training2.csv. So now what we'll do is we will also take a look at the test dataset, and we're going to upload, let's get the directory right this time, a second test, so Iris test CSV. Let's upload that, and eventually in our output we should see the results of the k-means. So let's see when this gets picked up. You can see that the actual output files are time-stamped every 15 seconds, and we've got let's call this, let's overwrite the last set of results, and we'll save that, and we'll just drag that in again to Sublime Text, and you can see here that we've got a similar set of results. So Spark streaming and streaming k-means gives us a system whereby we can enhance our training data set, so we can have the best training data to make predictions and continually update this model, whilst at the same time drop test data into the directory so that we can continually predict this test data.